Now we come to the application, another application which is very important. We can also compare EMFs of two cells using potentiometer. How do we do? For that also, we take the same circuit. See, these 2 points A and B, this is the potentiometer wire, this wire is potentiometer, and this, by now you already know that this is the auxiliary circuit or the primary circuit which is giving constant current to the potentiometer wire. Now this is the cell E or battery, E, rheostat and key K. Now this is providing constant current to the potentiometer wire. This is the primary circuit. Now what we are going to find out is the secondary circuit. Now we have to find out we have to compare the EMFs of the two cells. So then we will take two cells in the secondary circuit. See, we take this cell of EMF E1 and another cell of EMF E2. See, now we connect the positive terminal of both the cells to the point A. And see, this 1, 2, 3 is a two-way key. The central point of the two-way key is connected to the jockey through the galvanometer G, and this 1 point and 3 point, there is point 1 and 3 and 2 and 3. See, as I told you that this positive terminal of this cell and this A has the same potential. Now, what do? We do the same thing what we did there. What we do is that first we will close the key K so that the current starts flowing through a constant current starts flowing through the potentiometer wire. Now what we do is, now we insert the plug in between this 1 and 3. When we insert the plug between 1 and 3, then this cell comes in the circuit. You can see, because we have closed this, that means this cell is also coming in the circuit. Now what we do is that this galvanometer is connected to the jockey. As I already told you that this positive potential is connected to the point A. That means point A and positive have the same potential. Positive terminal of the cell has got the same potential. Now we have to slide the jockey on the potentiometer wire and stop where we get zero deflection on the galvanometer. The moment we get zero deflection on the galvanometer, we note down that point. Suppose J is that point. Now A, E1, J. It has got no current. So that is why we are getting zero deflection. We will note down that value of J. A, E1, this AJ. Let AJ is equal to L. So we have found out the length, balancing length, that is called the balancing length. So we have found out AJ, which is the balancing length. So we have found out, we know that is like E1 is the EMF of this cell. So obviously from here, E1 is equal to, let balancing length be L1 in this case. So E1 will be equal to KL1. We will get 1. Now what we do is, we take out the plug from here. Now this cell is not in the circuit. Now we insert the plug between 2 and 3. Now this cell comes in the circuit. Now this cell is not in the circuit. Now the second cell comes in the circuit, and we repeat the procedure. What we do for this cell, now we will slide the jockey on the potentiometer wire, and we will note down the point where we get the null point. That means where we get zero deflection in the galvanometer. Suppose that point is J dash. Okay. Now we note down AJ dash. Let that be equal to L2. So that gives us the EMF of the cell E2, because now E2 is in the circuit. So E2 is equal to KL2. So dividing 1 and 2, we get E1 upon E2 is equal to KL1 upon KL2. KK gets cancelled, this gets L1 upon L2. So here we are not getting the value, but we are just comparing the EMFs of the two cells. E1 upon E2 is equal to L1 upon L2. And we can also find out EMF of one of the cells if the other EMF is known. Suppose you know E1, or if suppose you know E2, you can find out E1, because E1 will be equal to L1 upon L2 into E2, so you can find out the EMF of the cell. So this is a very important application.